Okay, g'day, how you all doing? So we're going to do the video for Module 3 of Switching Routing Wireless Essentials, which is talking about VLANs. So let's get the PowerPoint up. Okay, so here we are. So VLANs, we're going to explain how network protocols enable devices to access local and remote network resources. And so we're going to have an overview of VLANs, so explain the purpose of VLANs in a switched network. We'll look at VLANs in a multi-switched environment. So basically, how are those VLANs transported across links between switches? VLAN configuration, so how do we configure it all? We'll look at trunk ports on switches, as well as dynamic trunking protocol, which can sort of automate these things. Okay, an overview of VLANs. So VLANs are logical connections with other similar devices. So placing devices in the various VLANs with the following characteristics. So provide segmentation of the various groups of devices on the same switches. Provide organization that is more manageable. So broadcast, multicast, and unicast are isolated into each individual VLAN. Each VLAN will have its own unique range of IP addressing. And the end result is you end up with smaller broadcast domains, which means traffic moves around more efficiently. Okay, so the benefits, as we said, smaller broadcast domains. So the smaller a broadcast domain, the more efficient traffic moves because there will be less broadcast and so less bandwidth wasted. Okay, improved security, so only users in the same VLAN can communicate with together. Unless, of course, there's a router joining them. But, of course, the router gives you an opportunity to actually put in some security between the VLANs, and so that's another positive. Improved IT efficiency. So VLANs can group devices with similar requirements, e.g. faculty versus students. You can reduce the cost, so one switch can support multiple groups or VLANs. And so prior to VLANs, if you had 3 separate LANs that needed to be defined for 3 different groups of users, you actually had to have 3 routers, 3 switches in every rack, basically. And so that may well have worked well if you had a lot of users, but if you don't have that many users, of course, you can do one switch and support all of those different VLANs. So better performance, more broadcast domains reduce traffic and improving bandwidth utilization, and simpler management. Similar groups will need similar applications and other network resources. So when you have a switch straight out of the box, there is only one VLAN defined on it, VLAN 1. And so that is the default VLAN. It is also the default native VLAN. It is the default management VLAN, and you cannot actually delete VLAN 1. No, while we cannot delete VLAN 1, Cisco will recommend that we assign these default features to other VLANs just to make it that a little bit harder for people to guess what we're doing. And so as you can see here, we've got a 24-port switch. So 1 through to 24 on the fast Ethernet and 2 gigabit ports as well. All members of that default VLAN 1. So that's the default setting. Now, you can have different types of VLANs, and so a data VLAN is dedicated for user-generated traffic, so be that web, email, talking to servers and things and the like. VLAN 1 is the default data VLAN because all interfaces are assigned to this VLAN. So a native VLAN is actually really only important on trunk links, and so all frames are tagged on an 802.1q trunk link except for those on the native VLAN. So again, by default, VLAN 1 is the native VLAN. I think I said it in the previous slide, but you can actually redefine that as well on a trunk by trunk basis. And then a management VLAN is what you use to remotely manage switches. And so this is used for SSH and Telnet VTY traffic and should not be carried with end user traffic. Typically the VLAN, that is the SVI for layer 2 switch. And so basically, as you've done in previous courses and chapters, up until now you've used interface VLAN 1 to set up a management interface. Well, and of course, the default management VLAN is VLAN 1 because it's the only one that exists. It is good practice to actually change that to something else. And so you'll probably see in a lot of labs and slides that Cisco likes to use VLAN 99. And that's great as an example, but again, I probably wouldn't use that either, just because probably the other people have seen that as well. So you should basically just pick a number and have that. And so you should actually have separate VLANs for all of these things. So of course you might have multiple data VLANs for all those different groups of users, and then you can define a native VLAN and a management VLAN as well. And another type of VLAN is a voice VLAN. So a separate VLAN is required because voice traffic requires assured bandwidth, high quality service priority, ability to avoid congestion, and delay less than 150 milliseconds from source to destination. The entire network must be designed to support voice. Now, the beauty of having a separate VLAN for voice is, it makes, of course, it's going to have a separate subnet as well, and so you can actually just tag traffic purely based on its source address or destination address, and so it makes it very easy even for the routers to identify what is voice traffic. Now, typically, what will happen is you can actually just use one switch port, and on that you can define both a data port and also the voice VLAN as well. And so this port here actually ends up being a trunk link because it's got the traffic of the data VLAN, which I can't see what it says about which one it is. Oh, it's down there, sorry, VLAN 20, and also VLAN 150 is for voice. And so you've actually got the traffic of two VLANs going over this link. Of course, the IP phone will take the voice traffic and then it will pass on the VLAN 20 traffic to the PC. So that saves having to add extra building wiring and extra switch ports, and makes things all very nice and efficient. Okay, VLANs in a multi-switched environment. Now, when you have VLANs with multiple switches, you need to basically create trunk ports. And so, as you can see here, we've color-coded these links here as being trunk links. And so, basically, on a trunk link, it's much the same as, if any of you remember what the terminology for a long-distance phone call was often called a trunk call. Basically, it's more than one VLAN's traffic over the same cable, over the one cable. And so trunk calls, or it basically meant you had actually the bandwidth of that link being shared by multiple phone calls in that case. But of course now we're talking about multiple VLANs. And so basically you can have more than one VLAN on the same port, extend the VLAN across the entire network. By default supports all VLANs, and you need to have a protocol that actually supports trunking. And so 802.1q is the industry standard these days, and so it actually adds an extra field to the Ethernet header for tagging to basically identify which VLAN a frame belongs to. Nearly said packet. Networks without VLANs. Without VLANs, all devices connected to the switches will receive all unicast, multicast, and broadcast traffic, and so it gets all very busy. And so we've got people from faculty, students and guests all on the same network, and they will all see, especially multicast and broadcast traffic, all the same multicast and broadcast traffic. And that's not necessarily good. So with VLANs, of course, you can separate those groups of users out, and also they won't see that extra broadcast traffic and multicast traffic and everything else. So without a layer 3 device connect the VLANs, devices on different VLANs cannot communicate. So because they're on different subnets, and also basically the switches partition the VLANs apart from one another, and so they can't talk to one another directly. And so you need a router to actually get that to happen. Okay, so we spoke about trunk links and tagging, and so here is a little more detail on that. So basically, IEEE 802.1q header is 4 bytes. That's actually inserted between the source MAC address and the type length field in the Ethernet header. And then in that tag, you have several fields. And so basically, when the tag is created, the frame check sequence must be recalculated. And when sent to end devices, this tag must be removed and the frame check sequence recalculated. And it should, of course, be the original frame check sequence. So basically, we have a 2-byte 2-byte field called type, and this is referred to as the tag protocol ID. And then there is user priority, canonical format identifier, and the VLAN ID is the last bit. And so as you can see, there's 12 bits left for VLAN ID. So basically 2 to the power of 12 means you've got basically 4,000 possible VLAN numbers. 4,096, I suppose, to be precise. Okay. Now, native VLANs, we did briefly mention them earlier. Now we'll sort of see what it means. So tagging is typically done on all VLANs. The use of a native VLAN was designed for legacy use like the hub in the example. Unless changed, VLAN 1 is the native VLAN. Both ends of a trunk link must be configured with the same native VLAN. If you get it wrong, you'll get messages all over the switches telling you so. Each trunk is configured separately, so it is possible to have a different native VLANs on separate trunks. And so basically, again, as we said, you should move it away from VLAN 1, just to keep the people guessing, I suppose. And so a native VLAN is one that does not get a tag. And so because both switches need to agree which VLAN is not tagged, that's why they have to match. And so, VLAN 1 typically won't have a tag, but of course, if you redefine it to VLAN 199, well, that would be the one that is not tagged. Now, the reason for having that is also all of the sort of housekeeping messages sent between switches will actually use the native VLAN, and so won't be tagged. Okay, so VLAN tagging. So the VoIP phone is a 3-port switch, and so the switch will use CDP to inform the phone of the voice VLAN. The phone will tag its own traffic voice and can set cost of service, and so that is basically the layer 2 equivalent of quality of service. The phone may or may not tag frames from the PC. So the voice VLAN tagged with an appropriate layer 2 class of service priority value. The access VLAN can also be tagged with that as well. It is not tagged. It can also be not tagged. All right. So show interfaces on that port, and you'll notice that you actually get 2 entries for VLAN. So there's access mode VLAN, so that's the data VLAN belonging to student VLAN, and then we've got the voice VLAN, which is VLAN 150. Okay, so how do we configure VLANs? So Catalyst switches like 2960s and 3650s support over 4,000 VLANs. Basically, most people will use VLANs 1 through 105. They're what's called normal range, but extended range VLANs can be used as well. Now, there are some differences. Basically, small to medium businesses would typically only need to use a normal range VLANs because, hey, 1,005 is a lot of VLANs. And so 1002 to 1005 are automatically created. You won't normally use the 1002 to 1005. And so there is a separate file stored on the switch called VLAN.dat, and that's where all that VLAN information is stored. And there is a protocol called VTP, Virtual Trunking Protocol, and that will actually allow switches to teach others switches about what VLANs they have. Now, extended range ones, often used by service providers. You can use them yourself, but so they're not stored in the VLAN.dat file. They're actually stored in the running config. They support they support fewer VLAN features, and they require VDP configurations. Okay, now, how do we create VLANs? And so basically you need to be in global config mode to start with, no big surprise there. And then you can just type in the command VLAN and its number. So VLAN 2, VLAN 190, whatever it might be. When you do that, you actually change into VLAN config mode, and you can actually give that VLAN a name. And so it could be staff or students or sales or whatever it might be. And so once you've created it, you can then get out, of course, or you could just do VLAN 191 and then carry on and so on. And so you can define multiple VLANs. So that defines the VLANs. And so if the student PC is going to be on VLAN 20, we will create the VLAN first and then name it. And so here's the example here, configure terminal, VLAN 20, name student. And then that's done. If you do not name it, the Cisco IOS will give it a default name of VLAN and its number, so VLAN 0020, and that will be its name. Not very informative, but yeah. And so once a VLAN is created, we can then assign that VLAN to switch ports. And so again, you need to be in global config mode. You then select the switch port that you're thinking of. And so if this particular host is plugged into port 10, you do interface fast Ethernet 0/10. And then from there, because it's going to be a member of a VLAN, you normally make it access mode, switch port mode access, which means this is an access port for a host. And then from there, switch port access VLAN and the number. So 20 if we're going by that previous example. And so that interface 10 would now be a member of VLAN 20, and only a host can connect to it basically. Okay, so we can assign the VLAN to the port interface. Only the device is assigned the VLAN, then the end device, once this device is assigned the VLAN, then the end device will need the IP address information for that particular VLAN. So here we've got student PC gets the address 172.17.20.22. So configure terminal, interface fast Ethernet 0/18, switch port mode access, switch port access VLAN 20, done. Now that port is a member of VLAN 20, so that's what the student PC that plugs into that port will, of course, be a member of. Okay, so an access port may only be assigned to one data VLAN. However, it may also be assigned to one voice VLAN for when a phone and an end device are off of the same switch port. And so that's a diagram you've seen before. So basically, you can just do another command called switch port voice VLAN 150, and that will actually set the voice VLAN. And so because we haven't defined it, we have defined it up here. And so you can also do a quality of service setting there as well to basically fill in some header information in that tag. We will want to create and name both voice and data VLANs. In addition to assigning the data VLAN, we also assign the voice VLAN and turn on quality of service for that interface. The newer Catalyst switch will automatically create the VLAN if it does not already exist when it is assigned to an interface. And so here it's saying if you miss this step, it will actually create it if you assign it to a port. QoS is beyond the scope of this course. Here we do show the use of the MLS QoS trust command. And so, yeah, that's about it. You don't have to worry about it too much. We won't be doing too much voice VLANing. Okay, so how do we verify information? And so you can do show VLAN, and you can also do show VLAN summary as well, but or brief. Yeah, I normally just do show VLAN, and that gives you that one that we were looking at earlier, where it lists the VLANs on the side and all the ports that belong to it. So display VLAN name, status, and ports, one line per VLAN per line. You use brief. display information about the unidentified VLAN ID number. You do ID VLAN ID, and so and then you can display information about the identified VLAN name. You can just use name and its name, or you can do a summary, which is what that is. Okay. So once you create the VLAN, you can do show VLAN, as I said, and you can notice that port 18 is still a member of VLAN 1 because all they've done is define the VLAN, which is called student. So once you do the switch port access VLAN 20 on port 18, it will actually move down. It will be removed from that and will be in a list beside that. So there are a number of ways to change VLAN membership. You can re-enter the switch port access VLAN command, or you can do no switch port access VLAN command, and that will put it back to VLAN 1. So show VLAN brief or interface switch port commands will actually tell you what VLANs it belongs to. Okay, so how do we delete VLANs? So basically, no VLAN 20 would delete it. Caution, before deleting a VLAN, reassign all member ports to a different VLAN. Basically, the reason you do that is all those ports will actually now not be able to connect to anyone or do anything. So if you delete VLAN 20 before you've reassigned those ports, those ports will actually be able to talk to no one. Some of the more paranoid amongst us actually do that intentionally. They make all the ports a member of VLAN 13 and then delete VLAN 13, and then none of the ports can talk to anyone. But then, of course, when you do create a VLAN, create VLAN 20, you can make ports members, and so those ports that have had it defined will work, while those ports, if someone plugs into those when they shouldn't be, they won't get anywhere. But anyway, so to restore to factory default, unplug all data cables, erase the startup config, and delete the VLAN.dat file. That's actually how you reset a switch. So there's an extra step on a switch compared to a router. You've got to delete that file. Okay, VLAN trunks. So how do we configure that? So again, you need to pick your trunk port. So of course, on the 2960s, we've got 2 gigabit ports. That's probably a very good, one of those is a good candidate for a trunk port. Okay, now we've done switch port mode access where you have a host plugging in. Switch port mode trunk says, hey, this is a trunk port. And you can also, as I said, on a trunk by trunk basis, define which VLAN is the native VLAN. If you don't do it, it will be VLAN 1, and that'll work fine as long as that's what you need. But you can redefine the VLAN ID. And you can also, on a trunk port, specify the list of allowed VLANs. Now, if you don't do it, all VLANs will be allowed, but you can actually control what VLANs traffic can go where as well by using this command. And so that's basically how you do it. So I'm assuming we've got an example coming. Yes. So we're going to set up 4 VLANs in this scenario. So VLAN 10 is for faculty staff, VLAN 20 is for students, VLAN 30 is for guests, and VLAN 99 is native. So we're configuring fast Ethernet 01 as a trunk port. We'll do switch port mode trunk, switch port trunk native VLAN 99, because that's the new one we've created that we're going to use, and switch port trunk allowed VLAN 10, 20, 30, and 99. So 1 isn't on the list, and so if there is anyone cannot join to 1, they won't be able to get through that trunk. So this assumes the 2960 switch using 802.1q tagging. Layer 3 switches require the encapsulation to be configured before the trunk mode. Because there were actually other trunking protocols in the past that were used, and so some you actually have to change it to be 802.1q. It wasn't always the default for Cisco. Okay, so verify trunk configuration, and so again here we've got switch port mode trunk, no switch port trunk native VLAN 99. So we've actually taken it back to VLAN 1. And so show interface that, and so access trunking mode VLAN 99. No switch port trunk native VLAN 99. Shouldn't be that. But anyway, I think there's an error in the slides. It shouldn't have no. So it's set as a trunk administratively. It's operational. It's using .1Q because that's the default. Native VLAN has been set to 99. Okay. All VLANs created on the switch will pass traffic on this trunk because we haven't specified which ones. So all can. Okay, to reset the trunk port, no switch port trunk allowed VLAN, no switch port trunk native VLAN. So we'll get rid of that. And so, yeah, that's the way you can reset the trunk link to a default state. Reset the trunk to an access mode with the switch port mode access. And so, of course, that will only support one VLAN. And apparently VLAN 1 is the one it's going to set. Okay, now dynamic trunking. Now, of course, we've set up trunk ports with a switch port mode trunk. That's great. That's manual, and it's actually the more secure way to do it. But switch ports can actually negotiate if there's a port. If there's cable running from switch to switch, they can actually negotiate whether they set up a trunk port or not. And so that's using dynamic trunking protocol, or DTP. It's on by default on Catalyst 29, 60s, and 50s. Dynamic auto is the default for those switches. It may be turned off with the no negotiate command. It may be turned back on by setting the interface to dynamic auto. Setting a switch to static trunk or static access will avoid negotiation issues with the switch port mode trunk or switch port mode access. So I've got to admit, switch port mode trunk is the way I always do it. And no negotiate turns off DTP. But to turn it back on, switch port mode dynamic auto basically means that dynamic means it will figure it out for itself, or auto, I think we'll talk about in the next coming slides. Okay, so basically switch port mode command has additional options. So switch port no negotiate interface configuration will stop DTP negotiation. So switch port mode access, of course, sets the host to be it sets it to be a host port. Dynamic auto is the default setting, and basically it means that if the other end really wants it to be a trunk, yeah, all right, I'll become a trunk. It sort of doesn't care. I'll be it or I won't be it. While the last two do certainly want it to be a trunk. And so instead of dynamic auto, if you set it to dynamic desirable, it means, hey, this port wants this to be a trunk. And so if the other end is auto, you will say, all right, fine, I don't care. So if you want to be a trunk, I'll be a trunk. And so that is basically, you only need to set the port on one end of the link to be desirable, and it will come up as a trunk, as long as it's not access at the other end. And so, of course, trunk is basically permanent. If the other end isn't in switch port mode trunk, as long as it's desirable or auto, it will come up as a trunk link. So this is, of course, a negotiation that goes on. All right, so here's a table explaining them all. And so basically, dynamic auto, remember, means I don't care. And so if both ends are I don't care, it's going to stay an access port. But if we've got dynamic auto and the other end does want it, well, hey, it will become a trunk. If dynamic auto talks to a port at the other end and it's manually set to trunk, well, it'll become a trunk. But if on the other end that port is in access mode, well, access mode doesn't want it to be a trunk, so it will stay access. Now with dynamic auto, dynamic desirable, it will always end up being a trunk unless the other end is an access. When it comes to trunk, it will always be a trunk unless it's access. And of course, these are manually set to non-compatible settings, and so you'll probably get very little out of it. And so access, of course, basically, you're never going to get anything but access out of an access port, except maybe nothing. Again, so if you've got trunk at one end and access at the other, they're incompatible. you will get warnings. So the default DTP configuration is dependent on the iOS version, and so you can do show DTP interface command to determine the current DTP mode. And so where are we? I've got to admit I haven't looked at this for a while. Negotiation timer, access timer. So best practice recommends that the interfaces be set to access or trunk and turn off dynamic trunking protocols, because there are actually hacks to get things to get extra access. All right, so switch port mode trunk, both ends, best way to do it. Okay, so module practice and quiz. All right, so we've hit the end. So VLANs are based on logical instead of physical connections. VLANs can segment networks based on function, team, or application. Each VLAN is considered a separate logical network. A trunk is a point-to-point link that carries more than one VLAN. VLAN tag fields include type, user priority, CFI, and VLAN ID. A separate voice VLAN is required to support VoIP. It's not required, but certainly is a good idea. If you've got a VoIP phone, it would be. Manage range, normal range, VLAN configurations are stored in the VLAN.dat file. Of course, extended range ones are stored in the config. An access port can belong to one data VLAN at a time, but may also have a voice VLAN. A trunk is a layer 2 link between two switches that carries traffic for multiple VLANs, quite possibly all of them. Trunks will need tagging for various VLANs. Typically, .1q is used. 802.1q tagging makes provision for one native VLAN that will remain untagged. An interface can be set to trunking or non-trunking. Trunk negotiation is managed by Dynamic Trunking Protocol, and it is a Cisco proprietary protocol that manages trunk negotiations. Okay, there is the logo. That is the end. And so that's the end of VLANs. And so, of course, we will have some labs in the future, or today, this week. And the next chapter is actually into VLAN routing. And so we'll look at how in that slideshow, we did say the only way traffic between VLANs can happen is if you've got a VLAN router. And so that's what the next chapter talks about, is how we implement that. All right, have a nice day, and I'll see you later.